Hello, good morning and welcome to the next video. Now in the last video I have explained you about the offline model testing where we go for true positive, true negative, false positive and false negative, and all those parameters I think you must be knowing under your machine learning course, and all those parameters again I am going to deal with in the next session also in terms of F1 score and other scores too. But before that, let us complete our model testing and then I will go to the test metric again once more. So, another model testing method is online model testing. Now, offline is without the model is being employed, you test the model and then try to find out the accuracy. Whereas the online is even a good or a great offline model testing pipeline won't guarantee that the model will perform exactly what you have set in the production system. So, what is the answer? Answer is there are always risks that can affect your model performance. So, the answer is your model may not be performing as per your expectation. So, what are the reasons? The reasons are following. Number one, human. Can we make mistake and leave bugs in the code? The chances of human committing the error are much higher. Okay, and leaving a bug in the code may be unintentional or sometimes intentional too. So, the person who is developing the code may make mistake or leave the bug in the code for others to not able to identify the bug and make the coding as a difficult part. This is also a human problem. Coming to the second problem, we have data collection, that is selection bias and incorrect data collection procedure may disrupt true metric value. So, here what I am saying is selection bias. So, what is the model or what is your selection on the test data, training data, and incorrect data collection procedure. So, you have not been able to get a data very smooth or a data collection method was wrong, and sometime instead of entering 22.22 you have entered 222.22. So, sometime your data collection procedure may be incorrect, okay, and it will disrupt the entire matrix value. So, whatever matrix value we have seen or we know about true positive, true negative, false positive, false negative, and then we have a precision and a recall and so on and so forth. So, all those matrix values will not be as per your expectation. Then changes, real world data may change and deviate from your training data set. This is the biggest problem leading to a unexpected model behavior. So, looking at these three parameters, you can see that the reasons are different: human, data collection and changes, and all this thing put together will give me a problem to solve. So, the only way to obtain certain model performance in the near future is to perform a live test. That is why we have to go for a online testing. Depending on the environments, such tests may introduce a big risk. So, whenever I am going for from a offline model testing to a online model testing, I always have a intuition of getting into trouble. So, risk factor is involved. So, a risk is a problem, risk is a actually not a problem, risk is a solution to find out will your model be able to perform in the real world in the online mode as per expectation or not. So, risk involvement has to be there. So, depending on the environment, such tests may introduce a kind of risk, okay, maybe smaller or maybe bigger. So, for example, model that assess airplane engine quality or a patient health will be unsuitable for a real world testing before we become a confident of their performance. Now, look at the two test scenario. A model testing for a airplane engine, definitely I can't take a high risk. Similarly, a patient health, I cannot take a high risk. So, this kind of environment, this kind of domain require a minimum amount of risk to be undertaken. That means your model has to perform very precision wise, very accurately, and the model has to undergo all kinds of testing procedure. Then only you can put the model into real effect. So, this is the background of our online model testing. So, when the time for a live test come, you will want to minimize the risk while maximize the statistical valid conclusion. So, the basic idea is, when we are putting the model in the actual environment, we have to minimize the risk, true, and at the same time we want a statistically valid conclusion to support it. Okay. So, thankfully there is a statistical framework for that purpose known as a hypothesis testing. Hypothesis testing we know from the probability and in our mathematical courses before we have done. Okay. So, hypothesis testing is the most important one, and hypothesis tells me that whenever I am doing something new, is it performing better than the previous one, or it is performing the same one, or it is performing a worst one. So, looking at the hypothesis testing, we will be able to know where my model is performing. So, when performing a hypothesis test, you can check the validity of some idea, that is your hypothesis, by collecting data and executing a statistical test. Imagine you need to check whether your new advertising model increases revenue from the advertising scene. So, Google makes money from advertisement. So, your model is, suppose let us say I introduce a ad model, I introduce more number of advertisement, I advertise more number of click you put, more number of advertisement I would like to put to you. So, for example, if you are buying a pair of shoe, I will give you a n number of pairs of the shoe which are similar to the shoe which you are buying. So, will my model will be generating revenues from the ad service? This is, let us say, our hypothesis. To do this, you randomly split all your client into two groups. One group uses the old advertising algorithm, while the other sees the ad recommended by a new algorithm. So, what I do? Very simple. You take two group, or imagine you have two kinds of algorithm. One is talking about the old, that means already it was there, and the other one is talking about the new one where you want to implement and the new algorithm. So, after you have collected a sufficient volume of the data, you can compare the two groups and measure differences between the two. Now, when I compare the two group, I will have three answers. Is the first was better than the second? Is the first performing as per the second, or the first is performing worse than the second? Okay. So, when we compare the two group and can find out the major differences between them, why do we need to bother about such a statistical, we can ask? Because we can answer the following question only to help our statistical. So, statistics play a very critical role in data science. Please revise your statistical background so that we are able to understand the applications of statistics in our data science. Nevertheless, let us see the answer and let us see the question. So, the questions it will answer is, how should I sort a sample individual into each group? So, when I am making two group, how do I make the sample, which group they will follow? Can my sample process distort the result on the test? So, when I am sampling my data, so it will distort the test or it will give me a good test. Second is, what is the minimum number of client in each group I should have? Can random fluctuation in the data affect my measurement? So, this is another problem, because the entire statistical data depend upon your probability or random selection. Number third is, how long should I run the test for getting a confident answer? Now, this kind of questions are very difficult and empirically we have to answer. Next one is, what formula should I use to compare the result in each of the group? Now, if you look at all the four questions in a very good way, it tells you a very good interesting property that what you intend to do are being available here. How many number of minimum tests I should do? Which hypothesis will be better? Similarly, how much number of epoch or test run I should do, so that I will get a confident answer, and will it be able to perform my answer in each of the group. So, this kind of questions give me a very good answer to my model testing. So, the experimental setup for a hypothesis test split the test target into two groups, one on the purpose. We can try to use a single group also. For instance, we can take one set of measurement with the old model, and after the first experiment is finished, we can deploy the new model with a new algorithm. then we can compare the two measures and measures made one after the another. What could go wrong? In fact, the result we get would not mean anything. Many things could go change in between our measurements, such as the following. Whenever I am deploying a model, oh, users have changes the preferences. No. First time I was buying a Bata shoe, now I am going to buy a Tata shoe. So my preference get changed. First time I bought a mobile, but now I am not very happy with my mobile, so I'll go to the prefer another user mobile. So user preferences keep on changing. Second, general user mode. Third, popularity of our service. Next is average user profile and any other attribute of the user of a business. So you can see that before our model really test two hypotheses, if these things are changing, these are invariably unknown answers to our model. So this model may not perform as per expectation. So what we do? We just put the hypothesis in place, and I have shown you a diagram here. I put the data into two form, one is the test, another is a control. So all this hidden effect could affect our measurement in a unpredictable way, which is what we want to do. We want to control, we want to put things into two way, one is a test form, another is a control form. Okay. So in the test we put a hypothesis, under the control I have a question mark, that means there is no hypothesis. Hypothesis has to be tested under the testing condition. So we must select this group in such a way that the only difference between them is our hypothesis. It should be present in the test group and missing from the control group. Okay. So I will take the next example next time, and I will talk about the medical control. And whenever a new medicine has to be introduced, it will be tested upon the people, and then if the hypothesis of the testing gives me a good result, then I will be able to put that medicine into the market, otherwise I will not be able to put the medicine in the market. So with this I stop here, and thank you so much.